To build a user interface for our application in Angular, we create a template with HTML. To really power up that user interface, we need Angular's data binding and directives. Welcome back to Angular 2 Getting Started from Pluralsight. My name is Deborah Kurata, and in these next two modules, we create our user interface using templates, directives, and data binding. Web applications are all about the user interface, and Angular makes it easier to build rich and powerful user interfaces. Angular gives us data binding so we can easily display information and respond to user actions. With Angular directives, we add logic to our HTML, such as if statements and for loops. And with Angular components, we build nested user interface fragments, such as an image rotator or rating stars. We've seen that an Angular component is a view defined with a template, its associated code defined with a class, and additional information defined with metadata and set using a component decorator. In these next two modules, we'll focus on techniques for building the template. In this module, we evaluate the different ways we can build a template for our component and demonstrate how to create a linked template for our view. Then we'll build a component associated with that template and use it as a directive. We'll detail how to set up data binding using interpolation and display the value of our component class properties in the view. We need some basic logic in the template, so we'll leverage Angular's built-in directives. In the next module, we'll look at additional data binding techniques. Looking at our application architecture, we currently have the index.html file and our root app component in place. So we have a working sample application, but it doesn't look like much. What we really want is a list of products. In this module, we'll begin work on the product list component to display that list of products. Let's get started. In the prior module, we built an inline template for our app component. We used the template property to define the template directly in the component's metadata. But this is not the only way we can build a template for our components. We can use the template property and define an inline template using a simple quoted string with single or double quotes. Or we can define an inline template with a multi-line string by enclosing the HTML in ES 2015 backticks. The backticks allow composing a string over several lines, making the HTML more readable. We use this technique to build our template in the last module. There are some advantages to defining an inline template using one of these two techniques. The template is directly defined within the component, keeping the view and the code for that view in one file. It is then easy to match up our data bindings with the class properties, such as the page title in this example. However, there are disadvantages as well. When defining the HTML in a string, most development tools don't provide IntelliSense, automatic formatting, and syntax checking. Especially as we define more HTML in the template, these issues become challenges. In many cases, the better option is to define a linked template with the HTML in its own file. We can then use the template URL property in the component metadata to define the URL of our HTML file. Let's use this technique and build a linked template for our product list view. Here is our ultimate goal for the product list view. The view has a nice heading. A filter by box at the top allows the user to enter a string. The user-entered string is displayed here, and the list of products is filtered to only those with a product name containing that string. The products are listed in a neat table with a nicely formatted header. The Show Image button shows an image for each product. The product name is a link that displays the product detail view, which we'll build later in this course. To make this page look nice with very little effort, we use the Twitter Bootstrap styling framework. You don't need to have experience with this framework, and if you're using the starter files, you don't even have to install it. I've already included what we need. But if you want to find out more about the Twitter Bootstrap styling framework, check out this link. Now let's jump into a demo and start building the template for our product list view. When we last saw our sample application, we had completed the app component. Now we want to add an external template for the product list component. By convention, each feature of the application has its own folder under the app folder. So let's add a new folder here and name it Products. In that folder, we'll create the template for our product list component. By convention, the name of the template is the same name as the component with an HTML extension. We'll call our product list component product-list.component.html. Let's widen that up a little bit. Now we are ready to create the HTML for our template. Let's start with the heading. We're using Twitter Bootstrap style classes here to display the content in a panel and display the heading as the panel heading. In the heading, we display product list. If you don't want to type in all of this code, you can copy it from the APM final folder provided in my GitHub repository, as detailed in the First Things First module earlier in this course. Next is the filter by. We define an input box for entry of the filter string, and we add text that displays the user-entered filter. We again use Twitter Bootstrap style classes to lay out the input box and text into rows. Now let's build the table. We use Twitter Bootstrap's table style classes. We have a table header. The first column header is a button to show the product image, and here is the table body. We definitely don't want to hard code in the products here, so let's leave the table body empty for now. So we have the start of a template defined for our component. Now what? If you said we need to build the component, you are exactly right. Remember the steps for building a component that we covered in the last module? We define a class. We add a component decorator to define the metadata and specify the template, and we import what we need. The only thing that's really different from the component we created in the last module is the template property. Here we are using template URL to define the location of our linked template instead of defining an HTML string. Let's jump right back to the demo and give this a try. We are back with the sample application exactly where we left it, and we are ready to build a new component. We start by creating a new file in the products folder. We'll name it using the component naming convention. .component because it is an Angular component, and .ts for the extension. Then we create the class, export, class, product list component. We're exporting this class so it is available to other parts of the application. Next, we decorate the class with a component decorator. It is the component decorator that makes this class a component. And we know what that underline means. We need the import statement. Let's pass an object into the component decorator with the appropriate properties. For the selector, we'll set PM products. We use the same prefix as in the app component to distinguish the selector as part of the product management application. Then we define the template URL. Here we provide the path to our HTML file. Notice that the path is relative to the index.html file, so we specify the app folder and product subfolder before defining the name of the HTML file. We'll look at relative pathing in the More on Components module later in this course. So now we have our template defining our view, our class which defines our associated code, and the component decorator that defines the metadata. Our component is complete, and we're ready to use it. But how? Here is our newly created product list component, and here is the app component we created earlier. Note that I've excluded some of the code here on this slide, such as the import statements and class details for a better fit. We'll see the complete code when we get back to the demo. When a component has a selector defined, as we have here, we can use the component as a directive. This means that we can insert this component's template into any other component's template by using the selector as an HTML tag, like this. The product list components template is then inserted into this location in the app components template. So this is the first step when using a component as a directive. Use the name defined in this selector as an HTML tag in another components template. When this template is displayed, Angular looks for a component that has a selector with this name. We could have hundreds of components in our application. How does our application know where to look for this selector? The application looks to the Angular module that owns this component to find all of the directives that are visible to this component. Remember the Angular module we looked at earlier in this course when we saw how to bootstrap our app component? Every Angular application must have at least one Angular module, the root application module, commonly called app module. I had provided the first cut of this Angular module with the starter files. Currently, our app module declares our root application component, app component. A component must belong to one and only one Angular module. Because the app module declares the app component belongs to the app module. The app module bootstraps the application with this component, so it is the first component that is loaded for our application. Our app module also imports the system browser module to pull in the features it needs to run this application in a browser. So this is what our app module currently looks like. An Angular module defines the boundary or context within which the component resolves its directives and dependencies. So when a component contains a directive, Angular looks to the component's module to determine which directives are visible to that component. What does that mean for us? Well, for Angular to find the PM products directive used in the app component, the product list component must also be declared in this Angular module. This is the second step when using a component as a directive. We need to ensure that the directive is visible to any component that uses it. There are two ways to expose a directive in an Angular module. We can declare the component in the Angular module as we show here. Or if the component is already declared in another Angular module, we can import that module similar to how we import browser module here. Now let's jump back to the demo and give this a try. We are back in our sample app. We defined a selector for our product list component here, so we can use it as a directive in any other component. Let's use it in the app component. Open the app component file. So instead of displaying my first component, we'll display our new product list template here. Replace the div tags with PM products. Are we ready to see our result in the browser? And our page does not display. Let's use our F12 tools to see why. The key part of this error is that we have a template parse error. PM products is not a known element. And with this error, Angular gives us a solution. If PM products is an Angular component, and in our case it is, then verify that it is part of this module. Ah, yes, we didn't do step 2 and declare it in our application's Angular module. Let's go back to the code. We'll open the app module and add product list component to the declarations array. Well, we're getting a squiggly line here. That means we have an error. Any guess as to what's wrong? If you said we're missing the import, you are correct. Everything we declare must be imported. We add all of the import statements at the top of the file. Okay, our syntax error is gone. Now let's try it again. There's our loading app message and our page. It's not complete, and it's not interactive yet, but we have the basics in place. So we successfully used our product list component as a directive. We added the selector as the directive in the containing components template. We declared the component to the application's Angular module, and we added the appropriate import statement. Now we are ready to power up our user interface with data binding and some built-in Angular directives. In Angular, Binding coordinates communication between the component's class and its template and often involves passing data. We can provide values from the class to the template for display, and the template raises events to pass user actions or user-entered values back to the class. The binding syntax is always defined in the template. Angular provides several types of binding, and we'll look at each of them. In this module, we cover interpolation. The remaining data binding techniques are covered in the next module. The double curly braces that signify interpolation are readily recognizable. The page title in this example is bound to a property in the component's class. Interpolation is a one-way binding from the class property to the template. So the value here shows up here. Interpolation supports much more than simple properties. We can perform operations such as concatenation or simple calculations. We can even call a class method such as getTitle shown here. We use interpolation to insert the interpolated strings into the text between HTML elements, as shown here. Or we can use interpolation with element property assignments, as in this example. Here we assign the inner text property of the H1 element to a bound value. Both of these examples display the same result. The syntax between the interpolation curly braces is called a template expression. Angular evaluates that expression using the component as the context. So Angular looks to the component to obtain property values or to call methods. Angular then converts the result of the template expression to a string and assigns that string to an element or directive property. So anytime we want to display read-only data, we define a property for that data in our class and use interpolation to display that data in the template. And if we need to perform simple calculations or get a result from a method, we can do that with interpolation as well. Let's give this a try. Looking at the product list template from our sample application, we hard-coded in the page title here in the heading. Binding the heading to a property in the class instead of hard-coding it in the HTML makes it easier to see and change when working on the code, and we could later retrieve this text from a file or database. Let's start by adding a property in the class for the page title. We'll open the component to the right and close down the Explorer. Here in the class, we specify the property name. We'll call it page title, and because we are using TypeScript, we define the type for this property. Lastly, we assign a default value, product list. With the page title property in place, we can now bind to the page title property in the template. We replace the hard-coded product list here with interpolation and specify the name of the property. Now, when this template is displayed, Angular assigns the string value of the page title property to the inner text property of this div element, and product list will be displayed. Let's see the result in the browser. With our binding, the page title appears as before. So we can confirm that it works. I've rearranged the windows so that we can see both the code and the browser. Now let's make a change to our page title here, and we immediately see it in the browser. So our interpolation works. So anytime we want to display the value of a component property, we simply use interpolation. Now we're ready to add some logic to our template. We can think of a directive as a custom HTML element or attribute we use to power up and extend our HTML. We can build our own custom directives or use Angular's built-in directives. Previously in this module, we've seen how to build a component and use it as a custom directive. We use the PM products directive to display our product list template. In addition to building our own custom directives, we can use Angular's built-in directives. The built-in Angular directives we'll look at are structural directives. A structural directive modifies the structure or layout of a view by adding, removing, or manipulating elements and their children. They help us to power up our HTML with if logic and for loops. Notice the asterisk in front of the directive name. That marks the directive as a structural directive. Let's look at ngIf first. ngIf is a structural directive that removes or recreates a portion of the DOM tree based on an expression. If the expression assigned to the ngIf evaluates to a false value, the element and its children are removed from the DOM. If the expression evaluates to a true value, a copy of the element and its children are reinserted into the DOM. For example, say we only wanted to show the HTML table if there are some products in a list of products. We use ngIf on the table element and set it to products and products.length. If the products variable has a value and the products list has length, the table appears in the DOM. If not, the table element and all of its children are removed from the DOM. But didn't we just say that an Angular module defines the boundary or context within which the component resolves its directives and dependencies? How will our application find this ngIf directive? Looking back at the illustration of our app module, we see that it imports browser module. Luckily for us, browser module exposes the ngIf and ngFor directives. So any component declared by the app module can use the ngIf or ngFor directives. With that settled, let's try out the ngIf directive. We are back in the sample application looking at the product list component and its template. We only want to display this table of products if there are some products to display. So the first thing we need is a property to hold the list of products. Where do we define that products property? In the components class, of course. We'll add a products property here. But what is the type of this property? Well, we want an array of product instances, but we don't currently have anything that defines what a product is. We'll have a better solution in a later module, but for now, we'll just define products as an array of any. In TypeScript, we use any as the data type anytime we don't know or don't care what the specific data type is. We need to populate our array, but where do we get the data? In many cases, we would communicate with a backend server to get this data. We'll look at how to do that later in this course. For now, we'll just hard code in a set of products. If you are coding along, consider copying a few of the products from the products.json file provided with the starter files under the API products folder. With the products property in place, we're ready to use it in the HTML. We want to put it on the table element because that is the element we want to add or remove from the DOM. Type star ngIf equals, and then our expression enclosed in quotes. We only want to show the table if there is a list of products, and that list of products contains some elements. Let's see what this looks like in the browser. We see the table header, so we know our table is displayed. Let's try this. Let's comment out the product property assignment. Bring up the browser again, and we see that the table disappeared. Now, if we uncomment out our table and look again at the browser, our table reappears. With ngIf, the associated element and its children are literally added or removed from the DOM. But notice that we still aren't populating the table with our products. Let's do that next. Another structural directive is ngFor. ngFor repeats a portion of the DOM tree once for each item in an iterable list. So we define a block of HTML that defines how we want to display a single item and tell Angular to use that block for displaying each item in the list. For example, say we want to display each product in a row of a table. We define one table row and its child table data elements. That table row element and its children are then repeated for each product in the list of products. The let keyword here creates a template input variable called product. We can reference this variable anywhere on this element, on any sibling element, or on any child element. And notice the of instead of in here. We'll talk more about that in a moment. For now, let's jump back to our demo. We are once again looking at the product list component and its template. Here in the table body, we want to repeat a table row for each product in the list of products. In the table body, we'll add a TR element for the table row, and in the TR element, we'll specify the NG4. Star NG4 equals, quote, let product of products, end quote. Next, we'll add the child elements. We'll insert a TD or table data element for each property of the product that we want to display in the table. We'll need to match them up with the table header elements. The first column displays the product image. Let's skip the image for now. We'll add that in the next module, but we'll still add the TD element as a placeholder. The next table header says product, so in this column we want the product name. We'll use interpolation to bind to the product's name by using the local variable product and a dot to drill down to the product properties. We want product name here. How did we know that property name? Looking here at the product list component, we see the product property names here. So these are the names we use in the interpolation template expressions. Next, I'll add TD elements for some of the other product properties. So for each product in our list of products, we will get a TR element for a table row and TD elements for table data. Want to see how this looks in the browser? Wow, we have our products. Doesn't that look nice? Well, our price is not very well formatted, and it doesn't have a currency symbol. We'll fix that with pipes in the next module. Looking back at the component, we defined an array for our list of products. In the template, we laid out the HTML to display one product. The product is displayed in a table row with product properties in the appropriate columns. Using an NG4 structural directive, we repeat this table row and its columns for each product in the list of products. So why is this NG4 syntax product of products and not product in products? The reasoning for this has to do with ES 2015 for loops. ES 2015 has both a for of loop and a for in loop. The for of loop is similar to a for each style loop. It iterates over an iterable object such as an array. For example, say we have an array of persons' nicknames. If we use for of to iterate over this list, we'll see each nickname logged to the console. The for in loop iterates over the properties of an object. When working with an array, such as this example, the array indexes are enumerable properties with integer names and are otherwise identical to general object properties. So we see each array index logged to the console. To help remember the difference, think of in as iterating the index. Since the NG4 directive iterates over iterable objects, not their properties, Angular selected to use the of keyword in the NG4 expression. Now let's finish up this module with some checklists we can use as we work with templates, interpolation, and directives. Checklists are a great way to recheck our understanding and our work. Let's start with a template. Use an inline template when building shorter templates. Then specify the template property in the component decorator. Use double or single quotes to define the template string. Or use the ES 2015 backtext to lay out the HTML on multiple lines. When using inline templates, there is often no design time syntax checking, so pay close attention to the syntax. Use linked templates for longer templates. Specify the template URL property in the component decorator and define the path to the external template file. This one is a more visual checklist. After building the template, we built its component and learned how to use that component as a directive. Remember our steps? First, we use the directive as an element in the template for any other component. We use the directive component selector as the directive name. We then declare the component so it is available to any template associated with this Angular module. We add the component to the declarations array passed into the ng module decorator of the Angular module. Angular's data binding was introduced in this module with a look at interpolation. Interpolation is one-way binding from a component class property to an element property. Interpolation is defined with curly braces and a template expression. That expression can be a simple property, a concatenation, a calculation, or a method call. Note that no quotes are needed when using interpolation. And we saw how to use two of Angular's structural directives, ngIf and ngFor. When using these structural directives, be sure to prefix them with an asterisk and assign them to a quoted string expression. Use ngIf to add or remove an element and its children from the DOM based on an expression. If the assigned expression is evaluated to be a true value, the element is added to the DOM. If false, the element is removed from the DOM. Use ngFor to repeat an element and its children in the DOM for each element in an iterable list. Define the local variable with let, and use of, not in, when defining the ngFor expression. In this module, we evaluated the differences between an inline template and a linked template, and we created a linked template. We then built a component for that template and learned how to use that component as a directive. We took a first look at Angular data binding through interpolation and powered up our template by using built-in Angular directives. Here, once again, is our application architecture. In this module, we started the product list component. Next up, let's discover more of Angular's data binding features and add interactivity to the product list template.